Welcome back to geometry. I want you to pause it after I talk about these a little bit, and I want you to think about how you would find the volume of these. Think about what kind of game plan you would come up with. Not the exact equation, we'll get into those, just you see prisms and half of a cylinder, what would you do? So pause the video, come up with what you would do. Okay, what I notice about each of these is that I have parallel sides, and those parallel sides are going to be a really nice clue for me. So because I have these triangles here, that's parallel to this side, that is considered the base of this shape, and so what I want to do is find the area of that base, which happens to be a triangle, and I'm going to multiply that by the height. In my second shape, my base, well, I can go a bunch of different ways. Doesn't matter. I can take the top here, and it goes with the bottom. I could have gone side to side, but I'm going to pick a base, and then it's going to be the area of that base times the height. In the next one, I definitely do have specific bases that are parallel. These two have circles. If I find the area of a half of a circle, multiply that times the height. That's the game plan. So we're going to be able to work on specifically finding those volumes. And we'll have one section that's a worksheet, and then tomorrow's will be out of the book. And I just want you to think about, does it matter if the sides of the prism are straight or if they're slanted or even if they're twisted? Is the volume actually going to change? So if I take a look at this first one, I'm going to find the area of the base. The base is, well, I'm going to pick this square down here. So that's going to be 2 times 2 for the square and times the height, which is 8. That's going to give me 32, and volume is cubed, so this is going to be inches cubed. I have the exact same stack of papers, and then I twist it. Does that actually change the volume? I have the exact same stack, so the volume has to be the same. It's going to turn out if I'm sideways, it's what's called oblique. If I'm twisted, that's not actually going to change the volume of the shape I'm looking at. So the general idea of the volume as a prism is it's the area of the base, and the base can be a whole bunch of different things, times the height. You have to be careful about measuring the height when the prism is slanted, but it's still base times height. So if we want to find the area of these, we look for the parts that have to be the parallel parts. We have triangles. The area of a triangle is 1/2 base times height of the triangle. That's why I'm using the 4 and the 3, because that's my triangle's right angle right there. And then I'm going to multiply that by 2. When I number crunch that, I have a volume of 12 centimeters cubed. The area of a trapezoid is a more complicated equation. It is 1/2 times the height. For the trapezoid, that's going to be 3 times what we consider the sum of the bases. And if we're looking at this shape here, I need this 14 here, and this guy is the same as this, it's 6. So it's going to be 14 plus 6. That's the area of the trapezoid times the height of this entire shape is 5. So this here becomes 30. 30 times 5 is 150 centimeters cubed. The base can be a rectangle, a triangle, a square, a trapezoid, a regular polygon, a whole bunch of different things. In each of those, we have different equations. If you do not have these memorized, make sure you have them written down before you move on. The equation for the volume of a cylinder is very close. The difference is we have an equation for the area of a circle. The base is a circle, pi r squared. That's the only difference. Again, we can have it at an angle. This is called oblique, and I'm still going to look for the height. So the volume is going to be pi times the radius of the circle squared times height. And I can number crunch this out. That's going to be 81 times 6, which is going to be 486 pi. Obviously, if I were calculating out to the nearest tenth, I would grab a calculator to punch in my pi button, or 3.14. Area of the circle, pi times 4 squared times the height, even if it's oblique, and that is going to be 112 pi centimeters squared. And if I want to number crunch that, 351.8 centimeters cubed. So we have these specific equations. We're just looking at what's the shape that I need to find the area of for the base. That triangle, I might even sketch it out to make sure I know what the parts are. This is a right angle, that always helps. 1/2 times 9 times 5 times 8. So the area of the rectangular prism is 180 meters cubed. And still gave me the radius, so I have pi times 8 squared times 14. And if I just straight up number crunch that, volume is always cubed. That's it. Those are the equations. So you're always looking at what is the shape of the base, find the area of that base, multiply by the height, make sure it's a vertical height, and you're done. You're going to have a worksheet. You don't have to print it out. You can write your answers on a separate page with your work shown and upload that for me on Google Classroom. Have a good day.